Thanks everybody for coming to the final session of the hybrid track. I'm Bill Jacobi, Solutions Architect Manager of Amazon Web Services. There's a rumor that there's an audience full of people in front of me. I can't really see you. There's about a 10% chance that I'll fall off the stage as well. But if none of that happens and there are folks here to listen, my topic today is running Microsoft workloads on Amazon Web Services. So I guess I would just start and ask a couple questions. How many people in here are currently running Microsoft workloads? Okay, essentially everybody in here is running Microsoft workloads, it appears. Maybe we can close the door in the back. My second question is, how many people in here want to know what's different about running Microsoft workloads in AWS versus on-prem? Okay, so the vast majority of you want to know what really is different when I run in the cloud. And just finally, how many people in here are looking for an easy button to just run Microsoft workloads in the cloud? Okay, and essentially that was everybody as well. Okay, so those are some of the topics I'm going to talk about today. And I won't recount this. This is the overall session abstract that I want everyone to, that was the basis for my agenda. And the agenda is really 3 parts. Why run Microsoft technologies and servers on Amazon Web Services? Some new announcements that took place in the last week. And then the bulk of the presentation will really be all about the architecture for running Microsoft servers in AWS, along with a hybrid implementation. So I'll really talk about both cloud and on-prem. And let's try to keep up. So that's the brief agenda. And what is AWS for Windows? So we have a huge team in Seattle, the Elastic Compute Cloud team devoted to Windows. And this team is building and optimizing Windows servers and Windows workloads on top of AWS. So there's a lot of things that they're focused on, both from a licensing perspective and from a technical perspective. So just to sort of dive into, the first and most obvious question is, why would you want to run Microsoft workloads in the cloud? And we have a whole number of reasons, and I have just some very short bullets on the answers to these reasons. But I guess in my view, the quotes from some of these customers actually say it better than the words. In the case of Lionsgate, Amazon Virtual Private Cloud gives us a secure environment with the flexibility and scalability we need to manage SharePoint with zero impact in our on-premises data center. So we've done a lot of work with security, and I'll tell you, I'll talk all throughout this session on what we're doing for security. Okay, so the second reason why people think about running Windows on AWS in the cloud is reliability. And again, to pick on a particular customer, Shaw Media said, before migrating to AWS, we experienced 10 to 20 hours of downtime per month. With Amazon, our downtime is significantly reduced. Our average uptime increased from 98.8% to 99.9% without re-architecting applications. Okay, so part of what's behind the statement by Shaw is that we have 99.95% SLAs across our major services. We have other additional SLAs that I'm not listing on this slide here, but 99.95% for Elastic Compute Cloud, which is compute, EBS Elastic Block Storage, volume storage, RDS Relational Database Service. Another reason why customers want to run Windows in the cloud has to do with performance. And again, picking on an example, this is one where a good friend of mine runs the Windows technology for Expedia. Expedia said, using AWS, we decreased average network latency from 700 milliseconds to less than 50 milliseconds. And Murari Gopalan went on to say, fundamentally, running on AWS enables a 230% CPU consumption efficiency in data processing. So running Windows in AWS is very high performance and very fast. Part of that is because we allow you to optimize instance types. Part of it is because we allow you an elastic model in which you can choose the instance that you need to run for best performance and not over provision, and perhaps more importantly, not under provision Windows workloads. So the next reason that people typically tell us, that customers typically tell us why they run AWS in the cloud is because it's familiar, because it really looks and really feels and really is like Windows. And I'll talk more about how the Amazon constructs map to on-premise concepts, providing familiarity of the infrastructure as well as Windows itself. And what Hess said in this case is, we didn't have time to redesign applications. AWS could support legacy 32-bit applications on Windows Server 2003, a variety of SQL Server and Oracle databases, and a robust Citrix environment. So this is a really important point, that there's nothing dramatic that needs to be done to move a Windows workload to AWS. There are lots of things that can be done to optimize an application, but to run an application unmodified as is, EBS volume storage being the equivalent of direct attached storage or SAN storage on premise works great. Running a Microsoft instance or a Windows instance on AWS and having it talk to networking and talk to DNS and talk to DHCP and talk to domain controllers, all of that kind of normal stuff that you're used to continues to run just fine in the cloud. I should mention a tiny bit about my fourth bullet, license flexibility. So for most Microsoft servers, we offer a license model of pay-as-you-go in which we're providing a license using the Microsoft program called SPLA, Service Provider License Agreement. What that means is that we're able to offer Windows Server, we're able to offer SharePoint Server, we're able to offer a new announcement I'll talk about in just a second. But we're able to offer running core Windows with a per hourly basis. Alternatively, if you have a software assurance agreement, an enterprise agreement with software assurance from Microsoft, you can bring your own licenses to AWS and for example, for Exchange or SharePoint or Lync, and you can use your own licenses directly. So there's a lot of flexibility on the licensing front as well as the technology front. Okay, so the next reason why people want to look at why would I look at AWS for running Windows? And to me, if we weren't cost effective, there wouldn't really be a basis for much of a conversation. And so one of the, again, I love these quotes. Slalom said, had we built our SharePoint 2013 farm in our other data center, we would have increased costs by almost 50%. When you compare our SharePoint 2012 farm to our SharePoint 2013 farm, AWS allows us to increase our computing power while reducing costs by 14%. And so for a whole variety of reasons, we can replace CapEx expenditures across the life cycle of asset refresh cycles with an OpEx model. We can provide economies of scale by providing virtual machine instances on a declining cost curve because we only charge you for the instance hours that you use, because we allow you to resize the instance sizes that you're using to a smaller instance size when there's lower demand. For all of these reasons, we can help you reduce cost. Okay, so the next reason why people look at why should I run Windows on AWS is because it's extensive. And being extensive relates to some of the services that we provide around Windows. So, and all the partner products that also run on top of AWS. So Airbnb, which I'm hoping to use for the first time in August. I've never actually reserved a room with Airbnb. Went on to say, as our company continued to grow, so did our reliance on the AWS cloud, and we've adopted all of the features AWS provides. AWS is the easy answer for any internet business that wants to scale to the next level. And so as I talk about the technologies behind, or the technologies that support Windows deployments, you'll see that there are a lot of technologies that create a cloud platform on which you can optimize Windows architectures. The next reason why people tend to run Windows on AWS is flexible. And we have a partner in the audience here, InfoReliance, who's our platinum sponsor for this event. InfoReliance has a lot of experience with federal agencies running Windows servers and workloads. And InfoReliance said, by deploying their on-premise Microsoft solutions like SharePoint and Exchange onto the AWS platform, combined with InfoReliance's ability for fully managed service options, our customers find the best of both worlds and the flexibility they require to meet their evolving requirements. So it's great to involve a partner. I'll talk about the technology things that are available, and I'll talk about the quick starts that we offer. But also, we have a lot of partners, and we have advanced partners like InfoReliance who are also great at running these Windows solutions. Okay, and so the overall summary are the things that I just mentioned. And what I want to do is sort of use the reasons for running Windows as a segue to talk about what are the technologies that allow you to run Windows on AWS, and what does it really mean to deploy Windows on AWS. And so first, I'll just state right up front, just like some of the previous presenters in this hybrid track, I'll be talking about the capabilities that you see here on the Amazon side, and I'll talk about how these Amazon cloud technologies are rough analogs and provide similar capabilities to what you have on premise with some additional magic and pixie dust that we use to optimize Windows environments. So before I sort of leap into the architecture piece, I just want to say this past week has actually been quite an important week in terms of announcements. We made two big announcements. One was that we announced a quick start for Microsoft Lync Server 2013, a quick start reference deployment. You can see the URL for it. And this is that for all of you who raised your hand at the end and said, I just want the easy button, this is clicking on a CloudFormation template, our JSON declarative description of all the things that need to be deployed to run an architecture, and in this case, the Lync environment. And this is now a one-button deploy available on this URL. Also, earlier this week, we announced that for the first time, we are providing a pay-as-you-go hourly license for SQL Server Enterprise Edition on Elastic Compute Cloud 2, on Elastic Compute Cloud. And this is the Enterprise Edition that supports always-on availability groups. So I'll talk a bit about high availability, and I'll talk about how always-on availability groups are a recommendation of ours. And so two recent interesting announcements. Okay, and now let's talk a little bit about Windows architectures on AWS and how we think about running Windows on AWS. So the first thing is that we recommend running critical workloads in two or multiple availability zones. An availability zone for us is a virtual data center or a data center configuration that's part of a region. And our regions consist of multiple availability zones. Each availability zone is its own virtual data center, and these virtual data centers are connected by high-speed fiber connections to each other, such that in total a region acts as one large data center. And each availability zone has separate power, separate cooling, separate connectivity to the internet, multiple internet providers to each availability zone. And so there's a lot of redundancy built into the AZ construct. And so our first general recommendation for Windows architectures is to place critical workloads in two or more availability zones. Secondly, I'll talk about virtual private cloud in just a minute. But using virtual private cloud, we recommend placing application servers in private subnets. And virtual private cloud allows you to set up public subnets and private subnets. And we recommend placing application servers just like you would on-prem in private subnets so they're protected or shielded from any kind of internet traffic. Lastly, as a general point about Windows architectures, we recommend deploying bastion hosts, remote desktop gateway devices, gateway servers, reverse proxies, and any other internet-facing devices or internet-facing servers in your public subnets. And our public subnets are essentially a DMZ kind of subnet. So these are some general guidance, and I'll drill down a bit deeper. So a general architecture that you might see for Windows on AWS would look like this. And I'll talk about Exchange, SharePoint, and Lync and SQL Server as individual architectures. But a general architecture would be based on this concept of virtual private cloud. This diagram that you're looking at shows an example of VPC. VPC is what lets you identify what are the, within a region, we have 11 regions. We have 32 availability zones across the world. Each one of our regions, just to give you a ballpark figure, as mentioned by our CTO at reInvent in 2014, each one of our regions has between 50,000 and 80,000 servers. So each of our regions are extremely large data processing facilities. And within a region, we have availability zones, like I mentioned. And with virtual private cloud, you're able to carve up an availability zone into subnets. And as you can see on my slide here, I've carved, within a single VPC, I've carved out paired private subnets and paired public subnets. And so if you look at this, typically clients would enter the Amazon cloud through the cloud icon, which is a representation of an internet gateway, and going through the public, accessing our internet gateway, you have access to the public subnets. The public subnets would typically keep, you would access your DMZ servers. We would typically place remote desktop gateways, the jump box, the endpoint for remote desktop services for you to RDP into for accessing and managing Windows servers. For inbound access, and the NAT servers provide outbound access for the servers that are in the private subnets. So VPC allows you to carve up, it allows you to define the address spaces of your private subnets, the address spaces of your public subnets. You can have any number of private subnets, you can have any number of public subnets, and you can tie them together. And in my mind, sort of the beauty of this architecture is that it really mirrors what most or all of you are doing on premise. With multiple subnets and interconnectivity between the subnets. And what you're seeing in the very middle is an elastic load balancer in which we're saying that traffic that comes into this architecture would be load balanced across the web servers in the two private subnets. I'll just say the NAT servers are used in our case in case a server that's booting needs to pull down updates from Windows Update. And a server on the internet can't get to a server in the private subnet, but using a network address translation server, a server in the private subnet can talk back to the public internet and get Windows updates or get bootstrap code that's needed to complete the bootstrapping process or download files from S3 or these kinds of things. Okay, so let's jump into some of the key architectural considerations are virtual private cloud. This is the way that you identify your network enclaves. The virtual private cloud, like I said, allows you to configure the IP ranges that you're using for cloud virtual machines, including public and private subnets. VPCs allow you to configure routing tables, so you're able to identify when traffic is in a private subnet, what other subnets can traffic flow to. Is there traffic that cannot flow to other subnets? So you can control at an instance level, at a virtual machine level, what traffic is allowed in and out. And at a subnet level, you're allowed to control traffic in and out. And controlling traffic at a subnet level takes place through routing and takes place through network ACLs. So I'll say, so these are the things that you set up with a VPC. There are sort of two guiding principles in how we think about architectures, security and administration. And in terms of security, we offer security groups. A security group is a firewall that we would place around instances, and the security groups would be a firewall that defines both ingress and egress. You can identify protocols, ports, source destinations. You can identify those capabilities for creating a firewall around your EC2 instance. In addition to that, you can use the Windows firewall, or you can turn off the Windows firewall if you want to use just the Amazon firewall. We have network ACLs for protecting subnets. We also have a new feature called VPC flow logging, which is an auditing capability of all approvals and denies of network traffic. So if there's an attempt to access a server and that server is allowed and approved, that's logged with VPC flow logging. Alternatively, if somebody tries to access a server and they don't pass authentication, or they're using a protocol that's not allowed by the firewall, or for any other reason traffic's denied, we will log the results of all traffic incoming and leaving the VPC through this capability called VPC flow logging. Now, remote administration is the second principle. We want to allow you to administer what you're doing in Windows. And remote administration, I'll talk about how we manage remote desktop services. And last and finally, there's this concept of the principle of least privilege, in which the goal is to allow not only users to have the least privileges needed to accomplish their goals, but also to assign the least privileges to instances that are running, to assign the fewest restrictions, the fewest capabilities within Amazon Web Services, the fewest service rights within AWS to accomplish the things that they need to accomplish. So this security principle is surfaced in multiple locations, and I'll talk a bit about how we do this. I should also mention that when it comes to remote administration, you can either do remote administration over the internet, or you can do it from a corporate data center over a VPN or a direct connection, and I'll talk more about that. Okay, so I want to just jump and say a couple things about security which are different from what you have on premise. This security groups are the Amazon firewalls, and these are in addition to, or potentially instead of, using the Windows firewall. And the way this works, these red boxes around the web instance and the SQL instance allow you to set up these firewalls that we call security groups. So for the web instance, you may say the only protocol that will allow in will be TCP port 80, HTTP traffic. And any other packet, any other protocol that tries to access this instance will fail, will be denied. Alternatively, if you look in the private subnet, the SQL Server security group will only accept traffic on TCP port 1433. So by creating a firewall around these instances, we're able to secure Windows instances as a way to manage traffic in and out. Security groups are manage both ingress and egress. So I mentioned ingress, but you can also control both ports and protocols that are allowed on the egress side as well. Okay, so talking about it, so let's shift over to administration. How would you administer Windows instances? Essentially, you would administer Windows instances in the same way that you would on premise. We would recommend that you put a remote desktop gateway in your public subnet, in your DMZ subnet. You can use the remote desktop protocol that, how many of you know what RDP is? Essentially, all of you know what remote desktop protocol is. You can use you can encapsulate RDP over HTTPS and establish an encrypted connection. I'll talk more about that. What I would call a pro tip is to use Remote Desktop Connection Manager, and I'll show you a screenshot of what that looks like in just a second. In addition to now managing Windows servers with RDP means that you're using a full screen interface. Microsoft, I think, has done a really good job over the past few years of creating scripted administration capabilities of Windows servers via PowerShell. So you can also install PowerShell web access on your Bastion hosts, and you can do all of your configuration of your backend servers through PowerShell or through RDP through accessing the graphical interfaces. So what does this look like in practice? What this looks like is if we're encapsulating RDP over HTTPS, we would set up a security group that would say only allow traffic over 443. That might be called the gateway security group. And when you set up RDP in this way, you'll be proxying connections to backend servers by name. So if you're accessing Web 1 or Web 2, those servers will automatically be proxied from a 443 connection to a 1389 connection, and essentially a single access to a server name will give you login and access to that particular backend instance. So the security groups permit traffic, the remote desktop gateway proxies traffic to multiple backend instances, and the remote desktop gateway is essentially a single endpoint, and all connections do get proxied through that single access point. From the perspective of high availability, we would recommend putting these remote desktop gateways in multiple availability zones. So I'm showing only one here, but a best practice would be to use multiple availability zones. If you use multiple availability zones, you can use Route 53. You can use our DNS service and point to a single name for a remote desktop gateway. And if the particular server that gets resolved by that DNS name isn't available, Route 53 will do a DNS failover to the surviving server. Okay, so so this is a picture of what Remote Desktop Connection Manager looks like, version 2.7. This is a tool that we recommend if you're installing more complicated Microsoft Server architectures like Lync Enterprise or Exchange Enterprise, where you may have multiple servers and multiple roles. You can just click here and you'll connect directly to your backend instance. Okay, and let's talk a little bit about, let's switch topics from administration to Active Directory. So there's a couple key points that are important here. You use and you should think about Active Directory domain controllers in the cloud or on premise in the same way. They perform the same function. They serve as a security boundary. They provide IP addressing. The Active Directory sites that you set up provide the LAN connectivity for workstations to be authenticated by the closest domain controller within that site. So all the magic and all the stuff that happens with domain controllers on-prem are the same things that you would gain out of putting a domain controller in the cloud. Now, Virtual Private Cloud provides some capability above and beyond what domain controllers provide. VPC provides DHCP for domain controllers and servers, and you don't need to stand up a DHCP server. Just putting a server into a subnet in VPC will enable that server to get an IP address via the VPC DHCP service. We can also assign static IPs using a capability called the private IP field when you stand up an instance. We also recommend putting global catalog servers, running the global catalog server role so that if you have multiple domains, you can authenticate to multiple domains through any of your domain controllers in AWS. We also support read-only and read-write domain controllers. For a variety of reasons, we tend to recommend read-write domain controllers, and I'll talk more about that in just a few minutes. Okay, so before I get too deep into Active Directory from Active Directory as provided by Microsoft, we announced the AWS Directory Service at reInvent in November last year. And the AWS Directory Service provides essentially two things, what we call Simple AD and what we call the AD connector. Simple AD is provided by essentially an AD clone based on the Samba 4 open source technology, and it provides a compatible directory server to Microsoft Active Directory domain controllers. It supports user accounts, it supports group memberships, it supports domain joining EC2 instances. You can create an EC2 instance, and in the wizard in which you create the instance, you can just identify the domain that instance should join and make that aspect automatic. On the other hand, truth in advertising requires me to tell you there are things that you cannot do with Simple AD. The primary capability missing being that you can't extend the schema. So many of the Microsoft servers that I'll talk about in just a second require schema extensions that aren't supported by the AWS Directory Service. Now, we do provide another capability called the AD connector. So if you were to make a decision, if your agency or your organization made a decision that you didn't want to put users and groups and that kind of information in the cloud, you could use AD connector to proxy all directory requests back to native Active Directory on-premise. And so AD connector would be the way to essentially stand up a server, a domain controller in the cloud, or at least have domain capabilities in the cloud provided on-premise. Now, I don't really recommend this for the Microsoft servers because most of the Microsoft servers put a very heavy load on Active Directory, and if all of your AD requests need to go through a VPN or direct connect to on-premise, it's going to reduce the overall performance of those servers. Over time, AWS Directory Service will become more fully functional. I wanted to mention it because it becomes a common question. Most of what I'll be talking about today will be talking about using actual AD domain controllers. Okay, so I want to say a second about Active Directory hybrid deployments because most of you, if not all of you, have Active Directory deployed in your current on-premise environment. And so the idea here is that in order to create a hybrid deployment, and this has been mentioned, fortunately this has been mentioned in many of the other hybrid sessions earlier today, but if you use Direct Connect, you create a direct dedicated pipe between your on-premise environment and AWS, and you can also connect AWS with a VPN to your on-premise data center. And if you do this, you can set up a hybrid deployment in which you have domain controllers that are replicating from the cloud on-prem and from on-prem to the cloud. And you want to set up security groups to allow traffic in the same way I showed on my security group slide, allowing all the ports that domain controllers require. You also want to define Active Directory sites and subnets, both in the cloud and have them match what you and extend what you've set up on-prem. You also may want to configure this notion of this Active Directory concept of site link costs. So essentially, you want to have domain-joined servers and workstations talking to the closest domain controller. So there's a group policy called try next closest site. And if you use this group policy, then workstations in the cloud will find the closest domain controller in that site. And sites are typically defined as LAN-enabled segments as opposed to WAN-connected segments. And so you'll enable the highest performance to connect to the closest domain controller. So this is how. So we would recommend domain controllers both in AWS and on-premise. And to just dive into what this looks like a little bit. So if we had a forest if we had a forest that connected AWS and a corporate data center, it would look something like this, where we would connect AWS and on-premise through Direct Connect or VPN. And this is a very basic configuration. There are only, in the case of on-premise, there are only two physical locations, New York and Washington, D.C. And the first thing I would do is I would add a domain controller to AWS. This orange instance would be our third domain controller. And if this were all a single site, there's actually a problem with this architecture. If what you're seeing here is three domain controllers all represented a single site, you would have traffic from workstations potentially going to any of the domain controllers in this architecture. And that's potentially inefficient because a workstation in New York may be authenticated by a domain controller in Washington, D.C. or the cloud. So it really would make more sense to have a workstation in New York potentially talk to the domain controller in Washington, D.C. if DC1 were to go down. So let's just talk about that scenario for just a second. So if DC1 in New York were to go down, where does the New York client go for authentication? And that's really the question that we want to answer. And the way to think about this, the architecture that we recommend for this is really to create three separate domain Active Directory sites. So we would set up New York as AD Site 1, we would set up Washington, D.C. as AD Site 2, and we would set up the AWS availability as AD Site 3. And in addition to that, we would set up site link costs between these sites. And so because of a high-speed connection between New York and Washington, D.C., a fiber connection or an MPLS connection, If it's cheaper and quicker to go from New York to Washington, D.C., we'll assign a site cost of 50 and maybe a site cost of 100 to move between on-premise and the cloud. And by using this group policy called try next closest site, clients will use the lowest cost path to connect to their domain controller. My diagram here is very simple and it only shows one availability zone in the cloud, but if we had a separate availability zone in the cloud and a separate domain controller in that second availability zone, we would probably also assign a site cost between those two domain controllers in AWS separated by availability zones, and we might also have a cost of 50. And so that's how we would, generally speaking, manage replication and authentication traffic. Now let's switch topics here, and my presentation is designed to be sort of top-down in terms of the basic concepts, drilling into more specific concepts. So at least two of the Microsoft business productivity servers use SQL Server. SharePoint puts its content database in SQL Server, and Lync Server Enterprise Edition also uses SQL Server for storing real-time communication sessions and information. So let's talk about SQL Server in the AWS cloud. And obviously, many applications besides the business productivity applications use SQL Server. So first, we offer a service called RDS, Relational Database Service. The Relational Database Service, by the way, is different from remote desktop services. Amazon RDS is Relational Database Service. It's a managed database service that's used for managing multiple database engines, including SQL Server. We also support Oracle, MySQL, Postgres, and we support our MySQL variant that we built on our own called Aurora. And so RDS is fully managed by AWS. It's automatically patched. It's automatically maintained. We set up failover such that failover takes place automatically. You're simply creating an application that uses tables that you've set up in the database. And in the case of SQL Server, we take advantage of SQL Server mirroring to provide HA. We also support, in the AWS cloud, we support SQL Server Enterprise Edition, both 2012 and 2014. This is managed by you on an EC2 instance, and high availability is achieved using these Windows Server failover clusters and always-on availability groups, which I'll talk more about as well. And as of last week, we now have a SQL Server Edition AMI available for pay by the hour. So how does this work? How does SQL Server High Availability work? The way SQL Server High Availability works is through this concept of availability groups. Availability groups do not require a shared storage model. SQL Server availability groups allow SQL servers to talk to each other directly. The same basic concept of an availability group also applies to Exchange and Lync, and is the basic concept behind how each of these products provide failover clustering. So in my example here, what I'm showing is really a simple two-node cluster. You'll notice that we've assigned 3 IP addresses per instance. There's an IP address assigned for the operating system, an IP address assigned for Windows Server failover cluster, and an IP address assigned for the listener. The listener becomes kind of the cluster name, and you bind applications to the listener name such that if there's a failure in any one of the underlying servers, our Route 53 DNS service will automatically fail over to the surviving server. You'll notice that you specify a fully qualified domain name for the listener, so you never need to hard code a specific server name with SQL Server availability groups. And if there's a failover, your application doesn't need to know that the server name itself has changed. It'll all be abstracted through the DNS name, listed on my slide here as ag.availabilitygroup.awslabs.net. So the replication is done by SQL Server itself. Windows Server failover cluster uses a quorum concept. So if there's an even number of servers, so if there's a failure, in order to determine if there's really been a failure, you need to have an additional voter to determine which server is healthy. So if you have an even number of servers in a SQL Server availability group, you need to have a third server that'll be the tiebreaker, that'll be the voter to determine, which server is really active. And this quorum concept is common in Exchange and in Lync. The witness server is typically a file share, and the concept here is that if the primary fails, the secondary replica will still talk to the witness, and you'll still be able to create what's called node majority. You need to have at least 2 out of 3 servers identifying the surviving server in order to have a failover. So you would activate the secondary server as the primary. And the witness, by the way, doesn't need to be an actual file server. The witness server can be a SQL server or, for example, even a domain controller. However, if you lose all of an availability zone, you may want to put the witness server in a third availability zone. So let me show some slight examples of what I'm talking about here. So in order to do automatic failover of an even number of SQL servers, we would need to have this third machine, the witness server. And the witness server is what provides the majority voting capability. This is a bad architecture in case all of AZ1 were to fail. You then wouldn't have a quorum to determine that we need to fail over to AZ2. So the way that we handle this is typically by putting the witness server, or like I said earlier, another instance of SQL Server itself into a third availability zone. And many Amazon regions support 3 or multiple availability zones. Okay, so this is how we develop a general quorum. So let's switch gears, and if you understand this bit about how SQL Server provides high availability, it turns out that SharePoint becomes an incredibly easy architecture to implement. SharePoint 2013 high availability follows the model that I just mentioned in the database tier for SQL Server. It's a similar concept to on-premise. We do, so general guidelines, all critical workloads should be placed in 2 availability zones. So these servers I've been talking about, AD domain controllers, but also SharePoint servers, remote desktop gateways, forefront threat management gateways, NAT gateways, these should all be in multiple availability zones. Internal application servers that shouldn't have access or shouldn't be reachable by the internet should be in private subnets, and the remote desktop gateways would be deployed into public subnets. Now the web tier is made available through load balancing. So you can put multiple SharePoint web front ends in multiple availability zones and load balance between them using either the Amazon ELB service or using something like HA proxy or using NetScaler or using any one of the load balancing products that are in the Amazon marketplace. In the case of SharePoint, the application servers on the middle tier are natively load balanced by SharePoint when they're installed. So SharePoint will natively install crawl servers, query servers, sandbox application servers in a way in which there's native load balancing of the application servers. And lastly, the database tier high availability is achieved with SQL Always On. Okay, so it turns out that implementing SharePoint is relatively straightforward. And this is a diagram of, and this is a diagram of what an internet-facing SharePoint farm might look like. And I've highlighted here the SQL Server Always-On availability group, the private subnets and the public subnets. And this would all be set up in VPC. But if you can set up SQL Server Always-On availability groups, you've done 90% of the work you need to do, and the rest of the architecture turns out to be very, very straightforward. I should mention before I go on to Exchange that for all of these architectures, for SQL Server, for SharePoint, for Exchange, and Lync, our quick starts will represent the easy button and will create all the architectures that you're seeing on the slides here. So let me just say a couple words about Exchange. It's the same basic concepts in which critical workloads are placed in multiple availability zones. We're achieving high availability within the data center with site resilience between data centers. So this is where you would set up AD sites in different availability zones such that an AD site is always in an availability zone with high-speed connectivity, which is the expectation of an AD site. Each of these sites support the DAG concept, the Database Availability Group concept of Exchange. And so even though you have multiple Exchange sites, you have high availability of the Exchange mailbox data through this DAG concept, which is analogous to the SQL Server always-on availability group concept. We have a saying in Amazon that everything fails, and you should always plan for failure. And so in this architecture for SharePoint, we essentially optimize around failure domains. So we have a similar architecture here for Exchange that we have for SharePoint, in which we have paired subnets, paired public subnets and paired private subnets to represent the basic architecture of Exchange on AWS. And essentially, this is the same architecture in which you would have users potentially directly accessing an Exchange multi-role server, or alternatively, in the case of Exchange and Lync, you can add an edge server to this architecture. So an edge server would allow applications to come in from the internet and then be connected to an Exchange mailbox. So the way this works, the way an edge server would work is a remote mail server would come in. It would talk to, we would put an edge in the DMZ. The edge server would talk to the Exchange to it. This might be Exchange Server 1. And if it turned out that the mailbox that needed to be updated was in Exchange Server 2, Exchange, as a middle tier application server in this case, would communicate with Exchange 2 in the second availability zone. So the only difference between this and the prior diagram is that we've added the edge server to the DMZ. I should mention that the remote desktop gateway and the NAT server would also continue to reside in the remote desktop, would continue to reside in the DMZ as well. Okay, so let's talk for a minute about Lync. And in the case of Lync 2013, we also have a reference architecture. The guidance tends to be very similar here, in which we're dividing critical workloads across AZs, across paired AZs. And just like in the previous example, in this case, domain controllers would be split across paired availability zones. But in addition, the primary workhorse server of Lync is the Lync front-end server. The Lync front-end server would sit in a private subnet. I'll show you this in a diagram in just a second. And the Lync front-end server would handle the majority of the capabilities, IM, presence, web conferencing, web video conferencing. All the key workloads would be handled by the Lync front end, and supporting servers as well would be placed in private subnets. So just like in the case of Exchange and SharePoint, the remote desktop gateways would be deployed to public subnets, and we would support paired Lync pools in each availability zone to support DR and pool failover. Okay, so this is what a Lync Standard Edition reference architecture would look like. This is essentially, this is very similar to what I showed for Exchange and SharePoint. And if you break this into the Lync Extended Edition or the Lync Enterprise Edition architecture, the basic architecture is the same, but what we're doing here is we're breaking out the separate roles required for Lync Enterprise Edition into logical tiers in a private subnet. And so, whoops. So what we're showing here is that when we break out the Lync servers in Enterprise Edition, we may break out the persistent chat pool and the Office web app server and the mediation server. All of those would be broken out into a logical division in the private subnet. In earlier architectures, we created separate IP ranges for the private subnets for each of the backend servers, and we noticed over the years that a single private subnet is probably secure enough, but each of these logical divisions within a private subnet, in this diagram, it all represent a single address space or a single private subnet. You'll notice in the case of Lync Enterprise Edition that we're taking advantage of SQL Server mirroring to provide high availability of the database tier. Lync 2013 Enterprise Edition doesn't support the SQL Server always-on availability groups that I mentioned earlier, so we're required to use database mirroring. I should also mention that on May 1st, Microsoft announced what they called Skype for Business. So Skype for Business is essentially Lync 2016. It's the next generation of the architecture that you see here, although along with the change in architecture, they're also changing the name. But the basic architecture is just an iteration of what you're seeing here. Okay, and so in this diagram, as an enterprise implementation, we've also included the stress test servers so that you're able to test how many IM users can I support, how many voice users can I support, how many video users can I support, and so on. Okay, and it's all based on this basic VPC architecture. Okay, so I wanted to talk for just a couple seconds about how we've enabled Direct Connect. And I mentioned earlier, or how we've enabled hybrid. And I mentioned earlier that we enable hybrid essentially through two capabilities. Either a VPN between your VPC and the Amazon cloud and your on-premise network, or by using this technology called Direct Connect. And Direct Connect, again, is a private connection between your data center and the AWS region that you're connecting to. Typically, Direct Connect would go through a Direct Connect partner who's a colo provider. We have lots of Direct Connect partners, and this provides a direct fiber connection such that your traffic would never need to traverse the internet in order to get to the AWS cloud. A lot of people have asked the question, can you really run Lync on AWS? Does the latency kill you? Or for that matter, does latency kill you for the other Microsoft servers running them on AWS? And I wanted to just provide the results here of a test that we did out of our Herndon office, in which the round trip latency between on-premise workstations in Herndon, Virginia, communicating with our US West 2 region in Oregon had an average round-trip latency of 88 milliseconds over the internet, using the internet as the backbone to connect to AWS. Alternatively, and more securely, if you use Direct Connect, you're connecting directly to in this case, the US East region, and you're using the AWS, you're using our AWS backhaul to connect from US East to the US West region. And the real point that I wanted to make on this slide is that Direct Connect offers tremendous benefits in terms of lower latency and lower jitter. And so my example here, and this is a screenshot of a real example, is that round trip to Oregon and back is 59 milliseconds. And Microsoft Lync documentation says that you can hook clients up to a Lync infrastructure as long as you have 120 milliseconds or less latency. So we're well within the envelope of supporting real-time communication, East Coast, West Coast, for the Lync environment. I would also add that I think that these latency numbers also make a good case for why VDI is also a valid architecture. And remember, this is East Coast to West Coast. If you're in the national capital region and you're connecting to the US East region, your latency might be on the order of 10 milliseconds or something dramatically cheaper when you eliminate the cross-country hop. Okay, so that's Direct Connect. And I wanted to just mention a couple words about managing and monitoring Windows instances and your Windows servers. So we recommend running System Center in AWS. SCOM, System Center Operations Manager, runs great. There are management packs for all the servers that you see listed here. These management packs give you an in-depth, Microsoft has done a great job of providing way beyond perfmon counters for what's really happening in these servers. And Microsoft has done a good job of providing a correlation between statistics and metrics that are gathered and higher level business rules that tell you, do you have a really hot Lync front end? Do you have a really hot Lync mediation server? Do you have a really hot Lync edge server? And so on. And so we really recommend running these System Center Operations Management packs in the AWS environment as well. In addition, Amazon has a capability called CloudWatch Logs, and CloudWatch Logs enable you to monitor instance activity in real time. So these are all the things that you would probably naturally expect: CPU utilization, network in and out, reads and writes to storage. And Amazon CloudWatch Logs enable you to capture information about your instances that are running. But in addition, CloudWatch Logs enable you to capture custom logs. So if you want to capture Windows event logs, you can push them into CloudWatch Logs, IIS logs. You can do event tracing for Windows and push those logs into CloudWatch Logs. And then you basically have a single pane of glass for seeing all of your Amazon infrastructure statistics, as well as all the statistics that come from the Microsoft servers you're running and the Windows instances on which they run. Okay, and I have a link here for additional information about the CloudWatch Logs. Okay, and that is, so I wanted to just mention that I've talked about a lot of technologies here. We have what we call quick starts for all the servers that are listed on this sheet. If you want to stand up active, all of these are high availability implementations. So if you want to set up AD across multiple availability zones, the quick start will set that up for you. If you want to set up remote desktop gateway on AWS, if you want to set it up with or without HTTPS as a secure protocol for proxying to the back end, you can set it up without SSL and without certificates, or you can set it up with this single proxy to the backend servers. We have a quick start for SharePoint, Exchange, and Lync. The Lync quick start just came out about a week ago. A SQL Server quick start. We also have a quick start for PowerShell desired state configuration. And this is Microsoft's configuration management platform. It plugs in really well and works really well with CloudFormation. Microsoft DSC, desired state configuration, is based on a declarative model where you identify what are the capabilities and the parameters and the metrics that you would like your servers to adhere to. It supports both a push model and a pull model in order to achieve that desired state. It's kind of a topic unto itself, but we've put out a quick start deployment guide for how to get started with DSC in a Windows environment. Okay, and I think that takes you through the sort of basics of AWS and hybrid IT, DR. That's my time. I really appreciate you guys coming and listening.